Well, I thought we were going to get to our game, but we're not quite there. We got to talk about reference angles. So if you like degrees, it's going to be bad. So let's talk about a reference angle. A reference angle. Now, we call reference angles alpha, or maybe that looks like the Jesus fish to you. Now, this is the technical term for a reference angle. It needs to be between 0 and pi over 2. Or if we're talking degrees, it needs to be between 0 and 90 degrees. It needs to be in the first quadrant. But I take the reference angle game and I take it a step further. I add this. So while technically incorrect, this is going to be excellent for finding our answers. So this is my crappy way of writing it for a reference angle. Oops, let me change my font. I call it the distance. There's no distance. Back to the closest x-axis. Like, what? The distance back to the closest x-axis. So let's draw some angles in real quick. So if I was to give you an angle of pi over 3, well, pi over 3 is already theta's pi over 3. We are already in between 0 and pi over 2. Hence, our reference angle is just pi over 3. It's the same thing as the angle because we're already in the first quadrant. Well, let's stick with those 3's and let's go to 2 pi over 3. Now, where's the closest x-axis? It's over here. It's on the negative side. So we want to know, how far is it? How far is it to get back to the x-axis? How far do we have to continue to go to get the pi? How far is that? Now, reference angles are never negative. They're always positive. So we started with an angle of 2 pi over 3. And we want to know, let me change my colors, put it in the green, stay consistent. Well, how far away is it from 2 pi over 3 to 3 pi over 3? How far away is that? It's pi over 3. Oh. Okay. Let's do another one. Let's choose 4 pi over 3. Now, where's the closest x-axis? That's right. It's over on the negative side. So now we have to figure out, well, how far is it from 4 pi over 3 to 3 pi over 3? You know what I mean? What could that be? Dude, it's pi over 3. All right, well, let's go with this one. 5 pi over 3. What are we going to do with this? I wonder what the reference angle could be. Well, we got to figure out how far is it back to this x-axis. Now we're on the other side. The closest x-axis is right here. So this is the same thing as red and black. This is the same thing as 0 or 2 pi, but we don't want to choose 0. We're not going to get 5 pi over 3. We're going to look at 2 pi because we're in the fourth quadrant. We want to know, how far do we have to go? Well, if you multiply the top and the bottom by 3, you find out 2 pi is the same thing as 6 pi over 3. So how far is it from 5 to 6? It's 1. Oh my goodness, look how freaking simple the reference angles are. When you're in radians. Oops, you don't want that yet. So let me give you an angle. 11 pi over 6. Do you think you can figure out the reference angle? Yeah, I can. It's pi over 6. Let's try another one. Theta is equal to 142 pi over 3. Can you find the reference angle? Yep, it's pi over 3. Now I'm going to give you one that's a cheater move. What about 18 pi over 3? Is that just pi over 3? No. Do you know 18 divided by 3? It's 6 pi. So this reference angle is not pi over 3. So as long as the angle doesn't reduce, and you have a pi over 6, a pi over 3, a pi over 4, a pi over 2, shoot, you just take the number off. Look, reference angle, not reference angle. That's just a trick. But don't worry, you don't really see that trick ever because all the fractions will be reduced. So this is our game with reference angles. But what happens when you deal with degrees? 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees. Now let's find some reference angles. So let's start off and say theta is equal to, I don't want to use the same one I used before. Let's use something different. 30 degrees. Draw it in, like 30 degrees. Well, then, since we're already between 0 and 90, our reference angle is 30 degrees. Let's do another angle. Let's make this one 150. So if I was just to ask you, I'm like, well, what's the reference angle of 150? Could you just look at it and tell me the answer like you could with radians? Nope. You have to do a subtraction. Degrees suck. They're too much work. They're really cool because we understand them much better than radians. I mean, you tell me, all right, 4 pi over 3 radians. My brain doesn't see what that is very well. But for solving trig, come on, man, I'd much rather deal with radians than I would with degrees. So now we have to figure out what our reference angle is. How far is it to get back to the closest x-axis? So we have to take the difference between 180 and 150, and that's 30. That's the reference angle. I'm going to keep it consistent. Let's stick with this. Let's go with 210 degrees. Hence, our reference angle is the distance back to 180. Hence, it's 30 degrees. I'm going to go with the last one. Can you tell what angle I'm going to use next? Can you see it? Because I'm going to make one that has a reference angle of 30 degrees. And I'm going to go in the fourth quadrant. Can you see it? Can you see it? Can you see it? It's going to be 330 degrees. Because how far back to the closest x-axis are we? What's the difference between 360 and 330? It's 30. And that's how we do our reference angles with degrees. Now let me show you something absolutely terrible. 7,260 degrees. Find me the reference angle. No, you didn't. Nothing paused. Your internet's still good. I was just waiting. You'd have to subtract 360 degrees to get a coterminal angle. You're like minus 360. Dang, not big enough. We have to subtract that angle till we can get it down to be small enough, just at least between 0 and 360 degrees. Oh my goodness, you see how much trouble that would be? Subtract 360 a bunch of times so you can get it in between 0 and 360 degrees. I mean, we could do a trick like this, that 360, if you did 20 circles, that's 7,200 degrees. Oh, so you could subtract this thing out and say coterminal, not reference angle, but a coterminal. They terminate in the same spot. Our theta would be 60 degrees, and then our reference angle would be 60 degrees. That's a lot. But again, if I was to give you this in 131 pi over 6, you're like, bro, the reference angle's pi over 6. A lot simpler. We like radians. You might not like it yet, but students don't touch degrees by the end of this class. At least students that pass the class, they never touch degrees. They always try and stay away from degrees. So that's the game. Again, reference angles are between 0 and pi over 2, or 0 and 90 degrees. And we're going to continually think the distance back to the closest x-axis. And it could be, I say back, but it could be forward. You know what I mean? We don't have to necessarily go forward, backward. Just the distance to the closest x-axis is where we're going. Radians simple, degrees pain in the butt. So if you want to hang on to degrees, expect extra work. But at least you're going to understand where the angles go a little bit better. So, all right, we're going to start our game next time. With all my trig classes, you always have worksheets on how to find the exact value of trigonometric functions. That's where we're going, dude. See you in the next.